And for part A, so in this one we're asked to use Gauss-Jordan row reduction, reduce row echelon form. Okay, so remember this is the key. We're going to use reduce row echelon form. Then our final answer should be expressed as just a ordered pair, because what we're solving for is what x and y, and there's all these other things that can happen, but the way we do this is we use an augmented matrix. So we first have to set up the augmented matrix, which is going to be the coefficients and these constants on the other side, the answers, I guess. So it's a matrix that is 2, 3, and 1, 5, 4, and 6. The way I shall have you do this, the way we've been doing this, is we enter it in to a matrix. Let's just put it into A. So we go over to edit, and it is a 2 by 3. We enter the matrix 2, 3, 1, 5, 4, 6. I do second quit to get back to the calculation part of the screen. We're now going to take that matrix, we're going to get it into reduce row echelon form. So we're going to go over to math. I'm going to arrow up because I get there a little bit quicker. There's the reduced row echelon form. Do not use A. This is only reduced echelon form. It's not reduced row echelon form, or it's like maybe it's just row echelon form. Yeah, it's not reduced. So we want this one, RREF. If I could, I'd have you delete the A, but it's not. We just won't be using that one. So I pull that up, and then I need to tell which matrix I want it to do it on. So we've only got one anyway. We're going to do it on A. And so there's my answer. Now, for the part show your work, I've shown that I set up this matrix. The next step to show my work will be that I did RREF of matrix A, showing I know how to do that, and it became this. And for my final answer, this, remember, we translate back. This is saying 1. To translate, this is 1x equals 2 plus 0y if you want, but we don't have to put it. And then the second row tells us 0x plus 1y equals -1. So our answer, as they want it, as an ordered pair, is going to be 2, -1. Okay. But this is sufficient work, shown that I was able to get it. We're going to address the issue where there's no solution. If there is no solution, well, we'll do both in the next question. In fact, maybe we'll just include that in this one here. So we'll just keep going. And then we're also going to include how do I write something that has that is a dependent system. So this is not dependent. There is a solution, right? We got one's on the diagonal, zeros everywhere else. That's reduced at row echelon form. Here we are. If there was not an answer, in fact, let's see, I forget all the things I've done. There's our answer, 2, -1. Okay. The next question. Oh, everything went away. I didn't realize it would do that. Oh yeah. Okay. Now I know what I'm doing. This is very similar, except this on this question 6, they saved us the effort of getting it into reduced row echelon form, which we would have done the same thing. We would have started with some other matrix, just like we did, do the RREF, and then this is the answer we would have gotten. So I want to show you, I want to use this answer to show what it means. So on this one, notice there is no 1 here for the z. So this is an x, a y, and a z. There is no z. There's no 1 here, so it's not that z equals 1. But it's this last one is telling us that 0 equals 1, right? 0x, 0y, 0z. 0 equals 1. That's not true. No way. Doesn't work. It's not true. So this is a no solution exists. What do they want us to do? State that no. So this one, we just say no solution. Okay, we just tell it. Now I want to show you. I'm going to add one to here that wasn't in there. I'm going to add a C. I'm going to do the same matrix. And again, I want you to know I'm making this up, sort of. And then 0, 0, 0. If this had been our answer, notice it's pretty much the same thing, except now I've got 0 equals 0, which it's true. 0 does equal 0. Yes, that happens. So now this, in this case, this is a dependent. So what we do is we convert over. I want it in terms of x, but now in this case we're actually going to need to probably put it in terms of z, but we'll see. Let's see. So this first line tells us that 1x equals 4. The second line tells us that 1y, or I'll just put y, plus 2z equals 0. And so in this case, actually, y is equal to y of x, z is equal to z of x. Since x is the only thing that has a set answer, x is 4. So, you know, again, we would list it as an ordered pair. X is 4. It's not dependent. But what we're going to do is we're going to have to make it dependent on either y or z. Okay, so if I solve this for y, which would seem to be the easiest thing to do, subtract 2z from both sides. I then get that y equals negative 2z. So what that means is I've made, in this way, I've made it dependent on z. Give me z and I can give you y. What is y going to be? It's going to be negative 2z. So this one is dependent on z. Depends on z. The other thing I could have done, I could have solved for z and then it would have been dependent on y, right? So I would take this and then I would divide both sides by negative 2. And I get that z equals y, or negative y over 2. So I could also have written this as 4 y is just y, give me y, and then I can give you z. What is z? Z is going to be whatever y is divided by 2. It has a negative on it. Okay, so these are basically the same answer, but one depends on z. As you give me z, I can give you y. The second one depends on y, and again I'll take either one. Just get me because they're both correct answers. Okay, so that kind of goes back to what we were doing over here, right? Once you get it to reduce row echelon form, if you do, if there's a solution, boom, that's pretty easy. But if there's no solution, well, that's also pretty easy. But spotting it, 0 equals 1, okay, you can do that. But if 0 equals 0, this is probably the harder one. The C is writing it as in terms of a dependent equation. But you just basically have to transform the matrix back into equations, and then you solve for one variable, and that's your, whichever you solve for becomes the other one that wasn't solved for becomes the dependent one, right? It depends on z. Like in this case, the first time we went through, we solved for y, so the z was deep, it depends on the z. Second time we solved for z, and so the answer depends on y. Give me y, I give you z. All right, that's that.